In a previous video, I covered the basics of setting up a React.js app with AWS Amplify Generation 2. Today I want to share with you how to do the same thing but with Next.js. First, just to set the stage, what is Amplify? Amplify is a platform for quickly and relatively easily building full stack applications that use Amazon's many services that you're probably already familiar with, like Cognito, S3, API Gateway, DynamoDB, etc. Amplify Generation 1 provided a prompt-driven CLI. If you're curious about that, you can take a look at this article that I wrote. The link is in the description. With Generation 1, you could also use a web-based Studio UI. I can't really say anything about that because I didn't use it. Right now, I'm not going to spend time talking about Amplify Generation 1. In fact, Amazon recommends that if you're starting a new project, you should use Generation 2. I'll just say that if you tried out Generation 1 and you didn't like it, I think it's worth the effort to give Generation 2 a try. The main reason from my perspective, at least at this point, is that Generation 2 allows you to set everything up for your full stack app using TypeScript definition files in an infrastructure as code style. I think that works pretty well. Other promising looking features in Generation 2 relate to per developer cloud sandboxes and ways for developers on a team to work collaboratively on a project. So I haven't used those features, but they look promising, and I'll put a link in the description if you want to read about those. Now let's get to the subject of this video, which is getting started with Next.js and Amplify. As a prerequisite, you'll need to have an AWS developer account. Everything you need to play around with Amplify should fall under the free tier. At least everything I'm going to show you now shouldn't cost anything. There's documentation for setting up your AWS account for local development. Note that this part right here says that if you've already set up your AWS configuration locally, you just need to add the Amplify Backend Deploy Full Access IAM role. The app I'm ultimately going to build as a demo is a simple e-commerce site that allows users to rate and review products and add products to a shopping cart, add items to a shopping cart, and the payments will be processed with Stripe. This is just going to be a demo app. It's not really made for production, but I think it'll be just complicated enough to show how to do a lot of the basic use cases with Amplify. So we'll use the authentication that Amplify provides via Cognito, so users can sign in and sign up, and we'll use Lambda functions to connect our app with the Stripe API. So we'll go through different scenarios. For regular users, they can rate and review. If you sign in as an admin, you'll be able to create products and update them, delete them, etc. But just today, we'll just set up a basic app, the basic functionality for the admin to create a product, update one, and delete a product, including adding an image, and the image will go into an S3 bucket. So we'll have a chance to exercise various functions provided by Amazon Amplify. Before looking at any code, let's just take a quick look at what the app looks like at this point. So here's an unauthenticated user, an anonymous user who can add to cart. That functionality is not there, but all users, signed in or not, can see products. Obviously, they said dummy products, but it's a real cat, but it's my cat, but it's a dummy product. This sign in and create account dialog is provided by Amplify's Authenticator component. So if I sign in as a regular user, I'm signed in, and now I have the add review button as well as the add to cart button, and those are not functional right now. If I sign out now and I'll log in as admin user, then I have an add product button, so I can click there and so I want to then I can upload a file. I put those. So the file has been uploaded to S3. Click submit, and product is created successfully. If I go back here, I can see my wet cat treats product. I can now edit that. Then it improved, so increase the price. And then finally, this is a hard delete, but in production we'll implement some kind of soft delete so that it isn't really deleted, but it's archived. So now we no longer have the wet cat treats. And that's all kind of the only functionality that I'm going to demonstrate today. I'm going to just now, we'll look at the code to get that working, get the app started, set up, and be able to add, edit, and delete products. I set up my Next.js app using create next app and accepting the defaults. Then I CD'd into my newly created app and set it up as an Amplify Generation 2 app by typing npm amplify at latest. Now I want to install some dependencies related to React.js and Next.js. First, I install Amplify's UI React library. It's important to note, given that we're creating a Next.js app, that these are client components. Next, so that we can use Amplify's API server-side, we need to install this adapter. Now we can start our app locally and see it running in a browser. There's nothing special about it at this point. Let's put it in GitHub, and then we'll connect it to AWS Amplify. Once we do this, there will be continuous integration. That is, when we commit and push, deployment will be started. We can connect our repo to Amplify via the GUI. Click Create New App, then select your repo. Note that if you don't see your repo there, you might have to give permission to AWS Amplify. You can limit that permission to selected repos. Once the repo is connected, we can deploy our app. Eventually, it should switch to the deployed status. At this point, you can take a look around the Amplify UI, but we haven't created any users or group or done anything related to authentication. We haven't yet done anything with data or storage, so there's nothing to see here. Well, let's fix that now by actually creating something to see here. When we ran npm create amplify, Amplify generated for us an amplify directory, and within it an auth/resource.ts, a data/resource.ts, and a backend.ts file. These are the definition files for the services that our app will need. The only change I'm going to make to the auth/resource.ts is to have it create an admins group. We'll manually add a user to that group later. By default, Amplify creates a to-do data model. I'll replace that with a simple product model that has fields for a name, description, price, and an optional image. I'll give unauthenticated and authenticated users read access. By not naming specific permissions for users in the admins group, they will have all permissions, so they can read, write, and delete. I also want to be able to store product images, so I create a storage/resource.ts file. I provide a name for the storage bucket, a directory for storing the images, and then I specify permissions for access. Here we need to actually name the kinds of access allowed from admin users. Parenthetically, note that we haven't specifically told Amplify to use Cognito, DynamoDB, or S3. The abstraction could be a positive or a negative, depending on your point of view. Now I just import the storage resource file into backend.ts and edit to define backend. Once I commit and push these changes to GitHub, deployment is automatic. One change we see is the addition of the admins group. Amplify Gen 2 requires the backend to be configured for use with ESM modules rather than CommonJS. So I'm just going to specify the module type in package.json. I'm not going to talk about Amplify sandbox environments in this video, but I at least want to call attention to the feature, which you can read about here. Now I can start a sandbox for this project by typing npx ampx sandbox. Let's take a look at our deployed app. So here's the domain. And nothing shows up, no errors, because we haven't created any users or any products or nothing. Let's try creating an account. Now that I have a confirmed new user, I can go in and add that user to the admins group. Just do that. It's as simple as that. Now I can log in as my new admin user. And I see the add product link there because I'm an admin. Price and add that thing. And you can see that everything's working just as it did with the local version. So go into the store, to the homepage. We can edit items. And the edit is persisted, and we can delete items. So the deployed app works just the same as the local app, which is what we want. We already installed the adapter that Amplify needs to use its API server side. In addition, we need to create a run with Amplify server context runner function. Here in util/amplify-utils.ts, I import the create server runner function from adapter Next.js, which we installed previously. I also import the Amplify app configuration as outputs from amplify-outputs.json, and then I pass outputs into create server runner, and that gets us the run with Amplify server context function that we need. As the Amplify documents point out, you only need to call this create server runner function once, and we use the run with Amplify server context function throughout. We also import generate server client using cookies from the Next.js adapter so that we can create a cookie-based client. We'll use that to access our data from server-side pages. Note that we're importing our schema and providing that as a generic type so that we can get some type safety from our cookie-based client. I'll show you how we use that in a moment. We also set the default auth mode to IAM. I should mention now that even though this is a pretty small app, I'm not going to go through every line. Link to the repo is in the description, and if you have a specific question, you can put it in the comments. Let's next look at layout.tsx. As you can see, I'm wrapping everything in a client setup context provider, which is right here. Looking at that, we can see it's a client component. It does a couple of things. First, it calls amplify configure. Note that note the SSR :true part. This configures the amplify library. The amplify documentation explains that setting SSR to true instructs the amplify library to store tokens in the cookie store of a browser. Cookies will be sent along with requests to your Next.js server for authentication. We put an Authenticator provider wrapper around our child components. This will allow us to use the Authenticator hook and client components to, for instance, find out if the user is signed in or not. You can read about the Authenticator component here in the AWS Amplify documentation, and in particular about the authenticator.provider under advanced usage. Additionally, I created an admin context provider. This allows us to know in client components whether or not the user is an admin. One thing to note about admin context.ts is that I'm using Amplify Hub to set up a listener for auth events. So here we set up the listener when the component mounts, and listen for a signed in event and a signed out event, and when the component unmounts, we cancel that listener. This is the documentation for Hub, which says Amplify has a local eventing system called Hub. It is a lightweight implementation of a publisher-subscriber pattern and is used to share data between modules and components in your app. And I didn't see any Generation 2 specific documentation, so I think it works the same as Generation 1, and you can rely on this Generation 1 documentation for now, at least. So while we're looking at admin context.tsx, I'll just point out that the use authenticator returns an auth status, and that the auth status can be a value of configuring authenticated or unauthenticated. And we're only concerned about changes in the auth status. So we can pass in this function, which will mean that there's only an update when auth status itself changes. So we don't get any extraneous updates. Taking a look at the Amplify documentation, see that using use authenticator hook at your app level is risky because it'll trigger a re-render down its tree whenever any of its context changes value. So to prevent undesired re-renders, you can pass a function to use authenticator that takes in authenticator context and returns an array of desired context values. So to limit re-renders, that's why I'm passing in a context dot auth user. When we get a signed in event or a signed out event, we toggle our is signed in state, and that will cause us to do a check admin. And check admin uses this fetch auth session function, which is the client, not their server version. Remember, at the beginning I showed that there are server versions of fetch auth session and get current user. And we just look to see whether the user's list of groups includes admins, and that's how we tell whether the user is an admin. Staying on the topic of authentication, here's our sign-in page with the Authenticator component, which allows the user to sign in or create an account. You can see we have our check is authenticated function from amplify-utils, so that if you go there when you're signed in, you will get a message you are already signed in, and otherwise you're going to be presented with this auth client. And the auth client is over here. We import it into a client component. It doesn't work if we import it directly into a server page. So I'm just presenting the unadorned Authenticator client just the way it comes from AWS Amplify /UI React. By the way, if you're curious about doing custom authentication, like custom sign in, sign up, sign out, etc., that article I mentioned previously, the one that's based on Generation 1, all the material in there that talked about custom authentication is still relevant in Generation 2. So taking a look at page.tsx, which is the main page of the app and where we list our products. Note that we're using our cookie-based client, and we're setting an auth mode depending on whether the user is signed in or not. So if we look again at our data resource.ts file, you can see that we've allowed guests to read. So that means IAM, and authenticated and group means user pool. There's another option you can use, which is public, which will use an API key, but that is less secure, and I might as well use the more secure way. But it does mean that that I have to change the auth mode depending on whether the user is logged in or not. The product item component is pretty simple. Let's take a look at it. It uses an image component. Amplify's UI components are client components, and they don't work if I try to import them into a server component. So here's the image component. So you can see that is a client component, and I wanted to use this storage image component from Amplify's UI React storage. So that can only be used in a client component, so that's why this exists. Product item component also calls another client component, product item controls. This component takes advantage of the is signed in prop that's passed down from page.tsx and the use admin context hook to control which buttons are displayed. In product item controls, you can see that we're using the regular client from AWS Amplify /API to call delete on our product model rather than the cookie-based client we used in the server page to list the products. We set the auth mode as user pool because only authenticated members of the admins group are allowed to delete an item. Oops, back here. And we revalidate path. This eventually calls the revalidate path in the server action so that the list is updated with to show that the item has not been removed. You can see here that we're using our is signed in and is admin values to control the display of the buttons. One thing I almost forgot to mention, I created a middleware for this Next.js app so that only members in the admins group can access pages that are under the admin directory. And I did that by creating a middleware.ts file and importing the checkIsAdmin function that I created in amplify-utils. So if the user is not an admin, they get redirected to the sign-in page. Obviously, that's a really, really basic way of preventing non-admin users from accessing those pages, but we'll improve upon it in future steps. Now I want to look at the product create and update forms. To generate connected forms, which are tied to your data model, you have to install AWS Amplify /UI React package. You also have to have deployed a data model from your sandbox environment. Then you cd into the directory where you want the UI components to be generated, and you type npx ampx generate forms. Chances are you'll want or need to customize the forms in one way or another. Keep in mind that if you change your data model, you'll need to generate the forms again. So you need to consider how you manage your customizations and code changes. Amplify's connected forms are client components that only work if they're imported into client components. So I import them from the UI components directory into my product create and product edit component. Looking now at the generated connected forms, I made essentially the same customizations in both of them. In both forms, I made the auth mode explicit and set it as user pool, as only members of the admins group have permission to create and edit products. I imported the storage manager and storage image components that Amplify provides. Here I've commented out the original code that Amplify generated, where the image field, since it's a string, the generator just treated it as any regular string. So I added this code so that if there is an image, we'll use the storage image component and display that image. I added a button so to remove the image. And finally, I added the storage manager component where we provide as attributes the directory, number of files we'll accept, what kind of file types. So our image handling code is really simple right now, and it has some problems, and I'm just going to leave you with this as a challenge, something you can solve. See how you want to solve it. So we know from looking at from our data model that image is just a string value. It only expects to ever have one image. So if I upload another one, okay, well, that seems all right. Seems like it just replaced the image. That would be okay. What if I try adding another one? Looks like I have two images for my product, which might be a desirable feature, but if I submit it and take a look at my product, we'll see that for all intents and purposes, there's only one image, and if I go back to edit it, there's only one image there. So only one was persisted. So I would classify that as at least a bug and possibly an enhancement to be made. And there are different ways that you could approach it. You could say, in a work situation, you might be given acceptance criteria that are like, as an admin, I want to be able to upload a single image for each product. If a product has an image, then the form should display the image along with a remove image button. If the remove image button is clicked, the UI for uploading an image should be presented. So basically you'd have a toggling situation where you toggle between displaying the image and uploading an image. There are different ways you could approach this, but that would at least be more reasonable than the way it is now. Here's the second challenge. So suppose you're assigned a story with acceptance criteria like, as an admin, I want to be able to upload up to 5 images for each product. The product create and edit form should allow an admin to designate one and only one image as a main image. If the maximum number of images has been uploaded, then the upload functionality should not be displayed, and the admin should not be able to upload an image. The admin should be able to delete or replace images, though. Now, you might ask yourself questions like, as a developer, how do I handle existing products that have an image field with a string value now that I need to implement a feature that's better suited to an images field that is an array of strings? That is, suppose you're working on an existing app that has been in use, so there are lots of images already, and they've been stored as a single string in that image field. What are some ways to handle that situation? Another question, how at the data model level should I designate an image as the main image? Like, should it be the first image in the array? Or should there be a main image field that stores an index corresponding to an image in an array of images? That's just two possibilities of several that I can think of off the top of my head. In the real world, an experienced developer might well have implemented an images array from the beginning, even if the client or customer insisted that they would only ever want to have a single image, because experience says that online stores always have more than one image for a product. And in terms of the data model, it's more trouble to implement support for multiple images later. That is to say, anticipating future needs is worth considering. It's a judgment call. This is just my second video, and I'm still finding my way. And so I welcome any comments or suggestions you might have. So please leave them. Have a good day.